All right, let's do this. This is Elliot, and this is your GRE question of the day, or in fact, this is your GRE question of the day. Go ahead, give the video a pause, and first read through, see what you recognize here, what's familiar from other problems. If you're confident about jumping in, go ahead and do that. And in any case, when you're ready, you can unpause me and we'll walk through it together. All right, so this one says, if x is a positive integer, what's the smallest possible value of x such that 350x is the square of an integer? We should be recognizing here within the first few seconds, we have like number properties, integer properties going on. Happens in a lot of questions where they tell us, they're giving us information that something is a positive integer. Means we're going to be dealing with the properties of those positive integers. Reminder, integer just means a whole number. Negatives, positives, or zero, anything that's 0.0, that's a whole number, is an integer. And in this case, we know x has to be a positive integer. So what am I supposed to do here? What's the smallest possible value of x that'll make 350x a perfect square, or the square of an integer? Well, 350 is already kind of big. I don't know my perfect squares, maybe past about like 12 squared is 144 or something like that. So it's not just from having perfect squares memorized that we're going to work this out. Instead, there's a really important rule that they're testing your knowledge of here about how perfect squares work. And there's going to be a really important skill, which comes up on a lot of integer properties questions and a lot of questions that deal with squares. If we're not just doing algebra, then probably what we're going to end up doing is prime factoring. Have you been practicing your prime factoring? Do you remember what that is from school? Well, you will in just a second. So if you struggled with this one, no worries. In fact, you should be psyched because your quant score is about to go up right now. So the important rule that I'm talking about is a perfect square. We know it means something times itself. So what that means is when we prime factor, meaning when we express that number in terms of just the prime numbers you'd multiply to get that perfect square, it's always going to work out that it splits into two even groups. Let me show you what I mean. So let's take, for instance, like 36. We should all know, or we're going to know now, that that's 6 squared, right? Or it's 6 times 6. And if I go further, 6 is not prime. Let us quick time out. A prime number, what's a prime number? Those are the integers that are only divisible by 1 and itself. So 6 is not prime because I know that 6 is divisible by 2 and 3, right? So now this is the principle I'm talking about. Here's a group with a 2 and a 3, and here's a matching group with a 2 and a 3. Every perfect square, since it's something times itself, has to work out this way where when we prime factor it, those prime factors can be split into two matching groups representing some root multiplied by itself to make a perfect square. Okay, so that means the first thing that we need to do is evaluate the prime factors of 350. Then we're going to see what would be left over to be able to split it into two matching groups, just like the ones we were just looking at. And whatever we need to make those two matching groups, that will be the smallest possible value of x. Crystal clear, right? Okay, let me show you what I mean. So we're going to start by prime factoring 350. And a couple different methods to do this. So if you remember doing it the way your junior high math teacher told you to do a prime factorization, do what's most comfortable for you. For me and for most of my students, that's just doing it stepwise, starting from 2's, right? 2 is the smallest prime number, and then we'll take out any 3's, 5's, 7's until we're done, okay? So what I mean is first, we're gonna say that 350 is 2, and if we divide 350 by 2, we're left with 175. So we'll leave that 2. And now we'll say 175. Well, it's not even anymore, so there's no more 2's coming out of there. And do you know the trick with 3? If I add the digits, 1 plus 7 plus 5 makes 13. Since the sum of the digits is not divisible by 3, 175 is not divisible by 3. So we're not pulling any 3's out of there either. but it does end in a 5, and we know any number that ends in a 5 is divisible by 5. So we can say 175 is 5 times something, and either you need a calculator or do just a little bit of guess and check to get to that's 5 times 35. 35 still ends in 5, so I can pull another 5 out of there. 35 is 5 times 7, and now 5 and 7 are both primes. In other words, we can express this 350, the prime factorization we call it, is now just what's left with the prime factors. In other words, 350, excuse me, is 2 times 5 times 5 times 7. Okay? So now we know we need X because this won't split into 2 even groups, will it? Right? So we could have our 5 over here for our one group and a 5 over here in another group, but then I've got a 2 and a 7 left over, right? So now I want to make 2 equal groups so that 350 times X, whatever that X is going to make a root times itself. These 2 same groups, just like a minute ago when we had 2 times 3 and 2 times 3 in the other group to make the perfect square of 36. So we've gone the long way around, a lot of interpretation here, right? For not a ton of math to say that when 350 gets multiplied by X, we have to make these 2 equal groups. What are we missing? Well, if X was a 2 and a 7, then I would have these 2 equal groups, right? I would have a 5, 2, and 7 up top in my first circle, a 5 and a 2 and a 7 in my second circle, and 350x would be the square of whatever 5 times 2 times 7 is. We don't really care about that right now, okay? So make sure that's making good sense. What we're driving towards here is that X is going to have prime factors that give us 2 matching groups, because that's what'll prove we have a perfect square. We're now seeing, what does X need? It needs to have 2 times 7, and that's how we know the right answer here is 14. Okay, if I add that 2 times 7, I'll have my 2 matching groups, and I'll be sure that 350x is a perfect square. 2, 5, 7, or 10, these other answers won't do it, but 14 is what will give me 2 times 7, and answer choice E is correct. Maybe a little tricky, but you got the video. Watch it again. I'm sure you never get tired of hearing me explain math to you. But seriously, this one is worth having it dialed in for better or worse. Even though we're going to grad school, we're still going to rely on prime factoring quite a little bit on test day. So that's a skill that's really worth having dialed in. If you still have some questions or you just need some more help getting ready for the GRE, feel free to reach out to me on Instagram. It's @HersonTestPrep. Message me anytime. Come back and see us for another GRE question of the day, any Monday through Friday. And in the meantime, happy studying.